Swagatam, cover the mathematics classes. Gurubhyo Namaha. This is your Murali Krishna. This is the fourth video on the chapter Trigonometry. In this video, I am going to prove some derivations. Derivation number 1. Prove that for all values of theta belongs to R, minus 1 less than or equal to sin theta less than or equal to 1, and minus 1 less than or equal to cos theta less than or equal to 1. So for all values of theta, the extreme values for sine ratio is lower extreme is minus 1 and upper extreme is plus 1. Similarly, lower extreme for cos theta is minus 1 and upper extreme is plus 1. Or you can say lower limit, upper limit. Lower limit, upper limit. Now, proof. Now, to prove this one, I will take an inequality, quadratic inequality from algebra. We know that if x minus alpha times x minus beta less than or equal to 0, this implies alpha less than or equal to x less than or equal to beta, where alpha is less than beta. Real numbers. Now I am going to take help of this inequality to solve this item. Now we know that for all values of theta belongs to R, sin square theta plus cos square theta is equal to 1. So I take first one. First, take sin square theta plus cos square theta is equal to 1. Or I write, this implies cos square theta is equal to 1 minus sin square theta. Now, cos square theta is a square of something. The square of any real number is always positive. Square of positive number, square of negative number, both gives you positive number only. So cos square theta is always greater than or equal to 0. Cos square theta, since cos square theta greater than or equal to 0, this implies 1 minus sin square theta also greater than or equal to 0. This part I am going to take. Now 1 minus sin square theta more than or equal to 0. This implies sin square theta minus 1 less than or equal to 0. So this implies I can go for sin theta plus 1 times sin theta minus 1 is less than or equal to 0. Let sin theta is equal to x. So we have, this implies we have x minus minus 1 into x plus 1, x minus 1 is less than or equal to 0. Apply this inequality. X minus alpha times x minus beta less than or equal to 0, then x lies between alpha and beta. Here my alpha is minus 1 and my beta is plus 1. This implies minus 1 less than or equal to x less than or equal to 1, where x is equal to sin theta. Therefore, minus 1 less than or equal to sin theta less than or equal to 1. Hence true. Similarly, we can prove cos square theta also. Similarly, again, if sin square theta plus cos square theta is equal to 1. Technically say, first I will write sin square theta is equal to 1 minus cos square theta. Since sin square theta is always greater than or equal to 0, This implies 1 minus cos square theta also greater than or equal to 0. This implies cos square theta minus 1 less than or equal to 0. This implies cos theta plus 1 times cos theta minus 1 less than or equal to 0. Same height you will get. This implies we have cos theta minus minus 1 times of cos theta minus 1 less than or equal to 0. Again applying same inequality, we have minus 1 less than or equal to cos theta less than or equal to 1. Very important. So here this sin theta, the ratio of sin theta always lies between minus 1 and plus 1. So here we can write this as minimum value minimum value of sin theta is equal to minus 1. Maximum value of sin theta is equal to plus 1, or we can say range of sin theta is equal to the difference minus 1 to plus 1 close to 1. All these are applicable for cos theta also. What are the cos theta? Minimum of cos theta is equal to minus 1. Maximum cos theta is equal to plus 1, or range of cos theta is equal to minus 1 to plus 1 close interval. These are very, very important. The next concept is the values of trigonometric ratios for special cases. So when an angle is 0 degrees, what will be the value of the trigonometric ratios? The next one, if the value is 90 degrees, then what is the value of trigonometric ratios? This is the lesson. Of course, I am going to find the values of trigonometric ratios for 30 degrees, 45 degrees and 60 degrees. Very, very important to solve numerical questions. Number 1, first. Zero degrees. Okay, now let us consider a circle. Okay, now this is 0, x-axis and y-axis. Let point P somewhere here. Its coordinates are x, y. Join OP and draw a perpendicular line that is equal to here. And the radius of circle is r. And you know very well this ON length is equal to x and PN length is equal to what? Like this. P N A. This is x, this is y, and this is r. Now this is theta. When theta is 0 degrees, that means OA is not raising up to OP. There is no revolving. In that case, what happens? When the raise, you will get y. When they don't get, you won't get y. That means my y becomes 0. Whereas this n point, the n point go back to A. coincides with A. That means my ON will become OA. But of course, OA is nothing but OP is equal to R. In this case, therefore, if theta is equal to 0 degrees, my y is equal to 0, x is equal to R. This is the observation. In this case, now come to sin theta. In any right angle triangle, sin theta is nothing but pi by r, but y is equal to 0. Therefore, 0 by r is equal to 0. Similarly, cos theta is equal to x by r, but x is equal to r by r is equal to 1. Tan theta, tan 0, 0 degrees. Tan 0 is pi by x, 0 by x is equal to 0, whereas cot 0 is equal to x by y or x by 0 not defined. Similarly, secant 0 degrees is nothing but r by x, r by r is equal to 1. And finally, cosecant 0 is equal to r by y or r by 0, which is not defined. Generally, they take it as infinity denoted by symbol. If the angle theta is 90 degrees, what are the values of trigonometry ratios? So here, okay, so we have circle. We have circle, x-axis, y-axis, y. Let the point B, so where here, its coordinates are x comma y, OP is R, and this is equal to M, this is x and this is y. So my angle is this is theta. OP starts its journey from OX and it rotates an angle theta reaches to. And we discussed for different positions of P or different positions of theta, the y value and x value will also change. When theta becomes 90, what happens? Theta becomes 90, OX, somewhere here OP, the initial OP and OX both are same. It comes slowly, goes different positions of theta. Then this is x, this is y. Y, of course, this is x. If you observe carefully, when theta is increases, my y value also increases. When theta increases from 0 to 90, my x value will decrease. So when theta becomes 90, what happens? My y will become coincides with the OY. Straightway OP comes here. And this n coincides with 0. That means my y becomes R and x becomes 0. In this case, in this case, my x is equal to 0 and y is equal to R. So if I know all the three sides of the triangle, we can So we could derive the values of trigonometric ratios for the angle theta is equal to 90 degrees. Please draw. So we have values of trigonometric ratios for theta equal to 0 degrees and 90 degrees. Now I am going to derive values of trigonometric ratios for the angle theta is equal to 30 degrees and 60 degrees. Values of trigonometric ratios for theta is equal to 30 degrees and 60 degrees. So both the derivations same. In this case, what we do, ABC is an equilateral triangle. Where AB is equal to BC is equal to CA is equal to 1, angle A is equal to angle B is equal to angle C is equal to 60 degrees. What I do, I will draw a perpendicular line from A to BC. So draw perpendicular line AN to BC. Therefore, AN is perpendicular to BC, and therefore this AN is altitude. In equal triangle, altitude is same as gradient. That means N is midpoint of BC. Since BC is equal to 1 unit, NC is equal to half. Now I have a rectangle triangle ANC with the NC half, AC is equal to 1. If you apply Pythagoras theorem, you will get its height as root 3 by 2. Therefore, in right angle triangle, ANC. Now focus on 60 degrees. For this 60 degrees, angle C is equal to 60 degrees. For this 60 degrees, AN is the opposite side, NC is the adjacent side, and the hypotenuse is 1. Then easily I can calculate what is sine 60. So sine 60 degrees is equal to opposite side by hypotenuse, that means root 3 by 2 by 1 or root 3 by 2. And what is cos 60? Cos 60 degrees is equal to adjacent side by hypotenuse, that means half by 1 is equal to half. So we could find values of trigonometric ratios for the angle 60 degrees. Now for 30 degrees also I use same line. Now here ANC is a right angle triangle because AN is altitude, AN is also median, as well as AN is an angular bisector also. That means this total angle is 60, so this will be angle become 30 degrees. Now I will take 30 degrees as the subject. For this 30 degrees, NC is opposite, AN is adjacent, and AC is hypotenuse. So I use this one. In triangle, So we got values for 60 degrees and 30 degrees. The next one, I am going to derive values of trigonometric ratios for 45 degrees. Values of trigonometric ratios for the angle theta is equal to 45 degrees. For this, what I do, I consider a right angle triangle A, B, C, and I will take it as a isosceles right angle triangle. And you know very well, in isosceles triangles, these two hands are same, length same. So I do one thing, I take this as 1 unit, this is also 1 unit. By Pythagoras theorem, I get root 2. Of course, this is 45 degrees. In a triangle ABC is an isosceles triangle. Triangle where AB is equal to BC is equal to 1 and AC is equal to root 2. Angle A is equal to 45 degrees. So I know for this 45 degrees, BC is opposite side, AB is adjacent side, and AC is hypotenuse. Therefore, we have sin 45 is equal to 1 by root 2. Cos 45 also same 1 by root 2. Tan 45 is equal to 1 by 1. And cot 45 is also equal to 1. And finally, I want secant 45. Reciprocal of these, so we'll get root 2. And finally, cosecant 45 is also equal to root 2. So, we found values of trigonometric ratios for 45 degrees also. We could find all the trigonometric ratios for 0, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Please take it. I am going to tabulate all these values in a table.